Hello, in this lecture we will find the radius of the circle enclosed in a triangle. We have triangle ABC. Side AB of the triangle equals to 4 units. Side BC of triangle ABC equals to 3 units. And side AC of the triangle equals to 5 units. And we also know that the area of triangle ABC equals to 6 units squared. And inside the triangle we have a circle, and we asked to find out the radius of this circle. Okay, so first of all we will define the center of this circle as M. So point M is the center of this circle. Then the touching point between side AB and the circle will be called N. We can say that side AB is tangent to the circle at point N, and side BC of the triangle is tangent to the circle at point M, or the touching point between side BC of the triangle and the circle is called M. Again, side BC of the triangle is tangent to the circle at point M, and the touching point between side AC of the triangle and the circle will be called P. Again, side AC of the triangle is tangent to the circle at point P. Okay. In the next step, we will connect together points M and N by a straight line. And then we will connect together points. Okay, let's call the center of the circle O. I will change it from M to O because we have already point M here. So the center of this circle will be called O. Point O is the circle of the circle. Point O is the center of the circle. Let's connect point O and M together by a straight line, and then we will connect points O and P together by a straight line. So actually, line segment NO, line segment OM, and line segment OP are the radiuses of this circle, because of the fact that they all start from the center of the circle, that is to say point O, and ends at any point on the circle itself. And the definition of radius is any line segment in the circle that starts from the center of the circle and ends at any point on the circle itself. And actually those 3 line segments satisfy the definition of a radius. They all start from the center of the circle and ends at the point on the circle itself. Therefore, therefore they are all the radiuses of this circle. I will call it small r. And again, because of the fact that all the three line segments starts from the center of the circle and ends at a point on the circle itself, they are defined as the radiuses of this circle. And actually we have rule, I will call it rule number 1. Rule number 1 states that in any circle the radius and the tangent to the radius are perpendicular to each other. I will read again rule number 1. Rule number 1 states that in any circle the radius and the tangent to that radius are perpendicular to each other. Okay, or you can, instead of the radius, I will write down in any circle a radius Okay, so rule number 1 says that in any circle, a radius and the tangent to that radius are perpendicular to each other. So if, for example, we have a radius, let's call it R, and we have tangent to that radius, let's call it T, then the radius is perpendicular to the tangent. That is to say, this angle is 90 degrees and this angle is also 90 degrees. So in any circle, a radius and the tangent to this radius, to the radius, are perpendicular to each other. Okay, so we actually can implement rule number 1 in our circle, because we have here 3 radiuses and we have 3 tangents to those 3 radiuses. For that reason, they are perpendicular to the tangent. For example, line segment NO is the radius of the circle, and we have side AB of the triangle that is tangent to this radius. For that reason, angle ONA equals to 90 degrees, and also angle ONB equals to 90 degrees. Okay, because of rule number 1 that states that in any circle, a radius and the tangent to the radius are perpendicular to each other. So the radius is perpendicular to the tangent. That is to say, this angle is 90 degrees and this angle also is 90 degrees. And for the same reason, line segment OM is the radius of this circle, and we have tangent to this radius, that is BC. Side BC is tangent to the radius, and for that reason, according to rule number 1, the radius is perpendicular to the tangent. That is to say, angle OMB equals to 90 degrees, and also angle OMC equals to 90 degrees. Okay, and again, line segment OP is the radius of this circle, and we have tangent AC to this radius, and according to rule number 1, the radius is perpendicular to the tangent. That is to say, angle POA equals to 90 degrees, and also angle OPA equals to 90 degrees, and also angle OPC equals to 90 degrees. Okay? In the next step, we will connect together by a straight line points O and B. And we will also connect together by a straight line points O and C. And we will connect together by a straight line points A and O. Actually, the formula for the area of any triangle is the area of any triangle is equals to the base of the triangle times the height to the base divided by 2. Okay, this is the area of a triangle. Again, the area of any triangle equals to the base times the height to the base, all divided by 2. Or instead, the area of a triangle, we can use capital A. A is abbreviation for area. So the area A equals to the base times the height to the base, all divided by 2. So this is the area of the formula for the area of a triangle, base times the height to the base divided by 2 equals to the area of a triangle. So we actually can implement this formula in order to calculate the area of triangle BOC, the green triangle BOC. So the area of the green triangle BOC will be equal to the base of the triangle, that equals to 3 units according to what is given in the question. The base of the triangle times the height to the base. The height of the green triangle equals to the radius, because the radius creates 90 degrees with the base. Angle OMC equals to 90 degrees, and also angle OMB equals to 90 degrees. So the height of triangle BOC equals to the radius of the circle, all divided by 2. So the area of the green triangle equals to the base of the triangle times the height, that equals to the radius, all divided by 2. Or in other words, or we can say that 3 over 2 is 1.5, is 1.5 times the radius. 3 over 2 equals to 1.5. So 3 times r divided by 2 equals to 1.5 r. So the area of the green triangle equals to 1.5 times the radius. Okay, in the same way you can calculate the area of triangle AOC. The area of the yellow triangle, triangle AOC, equals to the base of the triangle, that is actually 5 units, times the height of the yellow triangle. The height equals to the radius, because the radius creates 90 degrees with the base. Angle OPA equals to 90 degrees, and also angle OPC equals to 90 degrees. So it is 5 times the radius divided by 2. So the area of the yellow triangle equals to the base, that is 5 units, times the height. The height of the yellow triangle equals to the radius, because the radius creates 90 degrees with the base, all divided by 2. And 5 over 2 is 2.5. So in total we got that the area of the blue triangle, triangle AOC, equals to 2.5 times the radius. Okay, and in the same way we will find the area of triangle AOB. So the area of the orange triangle, triangle AOB, the area of the orange triangle, triangle AOB, will be equal to the base of the triangle that equals to 4 units times the height of the orange triangle, that is actually the radius. The radius is the height because the radius creates 90 degrees with the base. For that reason, the radius of the circle is the height of the orange triangle, so it is 4 times the radius divided by 2. Okay, so the area of the orange triangle equals to the base of the triangle, that is 4 units, times the height. The height is the radius divided by 2. Or 4 over 2 is 2, so in total we have that the area of the orange triangle equals to 2 times the radius. Okay, and actually the area of triangle ABC equals to the sum of the areas of the yellow triangle plus the area of the green triangle plus the area of the orange triangle, because the triangle ABC contains those 3 triangles. Therefore, the area of triangle ABC equals to the area of the green triangle, that is 1.5 times the radius, plus the area of the yellow triangle, that equals to 2.5 times the radius, plus the area of the orange triangle, that equals to 2 times the radius. Okay, again, the area of triangle ABC, the big triangle, equals to the area of the green triangle, that is 1.5 times the radius, plus the area of the yellow triangle, that is 2.5 times the radius, plus the area of the orange triangle, that equals to 2 times the radius. Okay, and actually I will call it equation number 1. And 1.5 times the radius plus 2.5 times the radius equals to 4 times the radius, and 4 times the radius plus 2 times the radius equals to 6 times the radius. So the area of triangle ABC equals to 6 times the radius. Okay, we summarized this side of the equation, and we found that the sum of those 3 expressions equals to 6 times the radius. This is the area of triangle ABC, but we have already known that the area of triangle ABC equals to 6 units. It is given us in the question, so we can substitute the area of triangle ABC by 6 units square, because this is the area of triangle ABC according to what is given in the question. Okay, so we substituted the area of triangle ABC by 6, because the area of triangle ABC equals to 6 units square. So we have the equation that 6 equals to 6 times the radius. Now we will divide equation number 1 by 6, and we will get that the radius of the circle equals to 6 units, at 1 unit. Okay, we divided equation number 1 by 6, and we got that the radius of the circle equals to 1 unit. Okay, this is the radius of the circle, it equals to 1 unit. Okay, now I will summarize the lecture. Actually, we wanted to find out the radius of the circle that is enclosed in triangle ABC. We know that side AB of triangle ABC equals to 4 units, side BC of this triangle equals to 3 units, and side AC of triangle ABC equals to 5 units. And we have a circle inside the triangle, and we want to find the value of the radius of this circle. Okay, so we define the center of this circle as point O, and the touching point between side AB of the triangle and the circle is N. The touching point between side BC of the circle and the circle itself is M, and the touching point between side AC of the triangle and the circle is point P. And actually we can also say that side AB of the triangle is tangent to the circle at point N, side BC of the triangle is tangent to the circle at point M, and side AC of the triangle is tangent to the circle at point P. Okay? And we connected together points O and N. Actually, line segment NO is the radius of this circle because it starts from the center of the circle and ends at point N. That is a point on the circle itself. For that reason, line segment NO is the radius of this circle. For the same reason, also we connected O and M together by a straight line, and OM is, for the same reason, is the radius of this circle because it starts from the center of the circle and ends at point M, that is a point on the circle itself. And exactly for the same reason also, first of all, we connected points O and P together by a straight line, and line segment OP is the radius of this circle because it starts from the center of the circle and ends at point P, that is a point on the circle itself. For that reason, line segment OP is the radius of this circle. Okay, because the definition of a radius is any line segment in the circle itself that starts from the center of the circle and ends at any point on the circle itself is defined as the radius. And this definition is satisfied by those three radiuses. Okay, so we actually have rule number 1 that states that in any circle a radius and the tangent to that radius are perpendicular to each other. So if we have a radius, we called it R, and the tangent to that radius, that is called T, the radius is perpendicular to its tangent. That is to say, this angle is 90 degrees and this angle is also 90 degrees. Okay, so in any circle, a radius and the tangent to that radius are perpendicular to each other. Okay, so we can implement rule number 1 in our circle because we have here 3 radiuses and 3 tangents to those radiuses. For example, we have line segment NO, that is the radius of this circle, and we have tangent to this radius, that is side AB of the triangle. So, according to rule number 1, the radius is perpendicular to its tangent. That is to say, angle ONA equals to 90 degrees, and angle ONB also equals to 90 degrees. And for the same reason, line segment OM is the radius of this circle, and we have tangent to this radius, that is side BC of the triangle. And according to rule number 1, the radius is perpendicular to its tangent. That is to say, angle OMB equals to 90 degrees, and also angle OMC equals to 90 degrees. And we also have line segment OP, that is the radius of this circle, and we have tangent to this radius, that is side AC of the triangle. So according to rule number 1, the radius is perpendicular to its tangent. That is to say, angle OPA equals to 90 degrees, and also angle OPC equals to 90 degrees. Okay, so in the next step, we connected together points O and B by a straight line, and also we connected together points O and C by a straight line, and we connected also points O and A by a straight line. And we know that the formula for the area of a circle equals to the base of the circle times the height to the base, all divided by 2. Or instead, the area of a triangle, we can use capital A as the abbreviation for area. So the area A, the area of the circle, equals to the base of the triangle times the height to the base, all divided by 2. Okay, so this is the formula for the area of a triangle. Actually, we can use this formula in order to find out the area of the green triangle. Because actually the area of the green triangle equals to the base of the triangle that is free times the height to the base, that is the radius, because the radius creates 90 degrees with the base, angle OMC equals to 90 degrees, and also angle OMB equals to 90 degrees. And for that reason, the radius is the height of this triangle. So the area of this triangle, the green triangle, equals to 3 times the radius divided by 2. Okay, the area of the green triangle equals to 3 times the radius divided by 2, 1.5 times the radius. And in the same way, we can calculate the area of the yellow triangle. It is actually the base of the triangle, that is 5 times the height. The height of the triangle is the radius, because the radius creates 90 degrees with the base. So in total, the area of the yellow triangle equals to 5 times r divided by 2. That is the base times the height divided by 2. Or the area of the yellow triangle equals to 2.5 times the radius. And in the same way, we can calculate the area of the orange triangle. The area of the orange triangle equals to the base of the triangle, that is 4 units, times the height. The height is the radius, because it creates 90 degrees with the base. So the base, that is 4 times the radius divided by 2, is the area of the yellow triangle. Okay, 4 times the radius divided by 2. The area of the orange triangle equals to 2 times the radius. But in total, we can say that the area of the big triangle, triangle ABC, equals to the sum of the areas of the yellow triangle plus the area of the green triangle plus the area of the orange triangle. Okay? We presented this equality in equation number 1. The area of triangle ABC equals to the area of the green triangle plus the area of the yellow triangle plus the area of the orange triangle. In total, we got in this side of the equation 6r, because 1.5r plus 2.5r equals to 4r, and 4r plus 2r equals to 6r. So the area of triangle ABC equals to 6r. But we know it is given us that the area of triangle ABC equals to 6 units. It is given us in the question. So we can substitute the area of triangle ABC by 6. And we got that 6 equals to 6 times the radius. We divided equation number 1 by 6, and we got that the radius of the circle equals to 1 unit. Okay, the radius of this circle equals to 1 unit. Okay, thank you very much.